Hello, this is daily Leetcode problem, 8th of June. The question is continuous Subarray Sum. This is a very important type of problem. So here, given an integer array nums and an integer k return true if the nums has a good subarray. The definition of good subarray is subarray where its length is at least 2 and the sum of element of the subarray is a multiple of k. Okay, all right. Therefore, let us if the int length is equal to nums dot size, if length is equal to 1, return false. This is the base condition. Now it is asking whether there exists a good subarray or not. Let me do a little bit of sketching. I was just before this doing something. Let me explain it. Therefore, let us say we have been given this subarray, this array 23, 2, 4, 6, 7, and we want to find out whether there exists a good subarray. So there can be so many subarrays that exist in this array. Let us say we want to find a subarray ending at index 0, 1, 2, 3, 4 here, which is n minus 1 index. So now we find the sum of subarray ending at index n minus 1, beginning with n minus 2 or n minus 3 or n minus 4, whatever, and see if the sum is divisible by 6, where in this case k is 6. So an array ending with 7 and let us say the this element 6 plus 7, which is 13, it's divisible by 6. No, let us see another subarray and ending beginning at 4, the sum will be 17. Is it divisible by 6? No. Beginning at 2, ending at 7, sum is 19. Is it divisible by 6? No. Beginning here, I think it becomes 42. Therefore, it is divisible by 6. It's a good subarray because good subarray minimum 2 and at least 2. That's the only condition, so we can include the entire array. Therefore, a subarray which is equal to array itself, its sum is divisible by 6. So if we do this brute force logic, this is going to take big O of n square time. The reason is we want to fix the ending index and keep changing the beginning index and see if that array has the sum is divisible by k or not. So this will time out. If we did not find any subarray ending at 7 which did not divide by 6, then we will fix our ending index at 6 and do the same process from 4, 6, 4, 10. We'll check whether divisible 6, 4, 10, 12. Yeah, it's divisible. So we'll also find a subarray which is divisible by 6 and which is ending at 6, beginning at 2. Therefore, similarly, we will find another survey. So this way, this is the brute force. It will require two for loop, and it will solve the problem. But it is going to time out. Therefore, we need to find an optimized approach. So to do that, what we have to do, little bit of math is required. Let us say we have this. We know sum of array, sub array, which is from, let us say, index 0 to I, and we also know sum of array from index 0 to j. where j is greater than I. Now, to find out whether the subarray from index I to j will be divisible by k or not. So first thing, if this is sum 1 and from index 0 to I, and this is sum 2 from index 0 to j, then from I plus 1 to j, the value will be sum 2 minus sum 1. So it will be sum 2 minus sum 1. Now, actually we don't have to find sum 2 minus sum 1. To see whether this value from I to j will be divisible by k or not, we simply have to see the remainder which h produced when this is divided by k and remainder when this is divided by k. If both the remainder are same, either 0 or 1 or 2 or k minus 1, then we can say that sum 2 minus sum 1 is divisible by k. It's a discrete math concept, little bit required to solve this problem. So we just have to find out whether there exists uh, a subarray beginning from index 0 to I, where the if the remainder is same. So we can write it in the form of code. So we'll translate something like this. Um, I think for int I is equal to beginning from 1, I equal to 1 to I is equal to 1 to. So how do we write it in the code? We'll start from 1 to length and I plus plus and int sum is equal to nums 0, and where sum is going to store from index 0 to till index I, sum plus equal to nums I. We'll see if sum is divisible by k, then return true. That is, array beginning from index 0 till index I is divisible by k, we return 2 true. If it is not the case, we are going to check whether there exists a subarray from index 0 till index I minus 2, which has remainder same as sum. So let us say int remainder is equal to sum modulo k. And where do we find out the remainder which is same as sum modulo k from index 0 to I minus 2, where we have stored? We have not stored it. So let us form a set of integer st where we are going to store those values. So if not st dot empty and st dot find remainder, and is not equal to st dot end, so it means we find a remainder in this set which is equal to rem. Therefore return true, otherwise just insert this current rem and move forward. If doing all this we don't find anything, return false. So did not find. Now run the code. So three cases have been accepted. Let me submit and see how it goes. Oh, wait, six. I think I got why it's wrong because we don't want to. I think we can do something like nums 0, nums 1, and we can start this loop from 2. Now, is it going to help in any way? I think we are doing it right. Just little bit of. I need to declare the previous. Um, Let me think some. Let me stop the recording and think. I think the issue was inserting the current remainder and then started making the sub-arrays of size run and we got the wrong answer. Therefore, I think we need to create a variable where it's going to store the previous remainder. I mean, till index I minus 2. If this is some return true, if it's kind of current remainder, till index this, and we see if not stack dot set is empty, then we're trying to find this. Otherwise, set dot insert not the current but previous remainder, and now previous remainder becomes the current remainder for the. So next time it comes, it is going to do this, and I will copy this one as well. I will run this. Hopefully, it does not break. But it's breaking. So we are going to do this previous remainder, and I will check on that complete thing. Discuss one passage. Hopefully, let me submit it now. Oh, oh, true. Let me stop the recording. Alright, I think we had a little bit issue here. So we had to find the current remainder if it exists in the set or not. Let me submit it again. If it gives wrong answer, I will not post this video. Alright, again 1, 2, 3. 1, 2, 3 is failing. We got 1, 2, 3, 3, 6. So I think here at the bottom as well, I have to do something like if mm, uh, set attempt. So this is it. Even though I said I will not upload, but there was very small issue that I was doing wrong. So instead of initializing the previous vendor equal to 0, we need to initialize it to some model OK, which is first element, so that it's like good. That's it. I'll stop the recording.